I'm Julian, and I would like to talk with you about how we integrated Amplitude into our Forge app. I think when you watch this video, you have already developed your own Atlassian Cloud apps, or you even know the difference between Atlassian Connect and Atlassian Forge. We encountered the problem that user interaction is a black box with Forge apps. When you compare it with Connect, where you operate your own database and your own backend, you don't know a lot of what your users are actually doing within your Forge app. You can't just open your database and have a look how many user interaction there are. There's a solution for that. It's called Amplitude. It's a cloud service, and we know Atlassian uses as well. The things I will show you, you could accomplish them with other competitors as well, I think. But we choose Amplitude because Atlassian uses it as well. Unfortunately, due to the Forge limitations, like you are in a sandbox, a secure sandbox within the cloud, you can't just jump into the Amplitude documentation and do the things that are written down there, because you will come across some issues here. And this talk is about how we solve those issues. And at the end, I will share our code repository with a working proof of concept of a Forge Amplitude integration. And so you can use it for your own app. Just to be sure that we are all on the same page here, things you can do with product analytics and Amplitude, for example, is you can do things like get an idea of what is your most popular feature by tracking the user interaction, or you can get an idea of what the click path, the most common used click path within your app are, to know that your users understand your user interface. And you can additionally collect more data you won't get from any marketplace APIs, like which customer uses which configuration, for example. There are a lot of possibilities. Like I said, you can't just open this Amplitude documentation and do what is written down there, because you will come across some issues. I divided those issues into basically 3 categories: where to collect those data and where to store them, because you can't just pipe every click to Forge and then to Amplitude, and how to transmit them without hitting some Forge quota limits here. So let's start. The first step is easy. Here you see a screenshot of our Cloud App Linchpin Enterprise News. It's built with custom UI on React. And this is what this talk and the code example I will show at the end is basically about. Custom UI with React, what is pretty common, I think. The first step is easy. You probably want to pick some components of your app which are interesting. So we did that with our app and had the idea, for example, that it would be interesting how a user configures our news hub here. We faced some issues with integrating Amplitude for that pretty common use case. First of all, we wanted to have an easy solution, that it's easy for developers to sprinkle tracking within the app. And we had issues with the Forge limits, because, like I said, you can't just pipe every click to Forge, because there are Forge function invocation limits. And the last point is that we didn't want to risk losing data when a user closes the tab or something like this happens. The solution we came up, like I said, you can have a closer look on it when I show you the code, is we build a tracking context component that uses a React tracking library. It's an open source library from the New York Times, I think. And we build an event persistence layer with the local storage for that we can collect data and pipe it to the Forge backend every 10 seconds. This circumvents some Forge API limits, like the maximum count of function invocations. So we build bulks of events, of click events, and send them to the server. What is pretty cool is our tracking context component. It makes it possible that you have that method you can see here, track event, and you can just pass an action name to it and to track certain things when stuff happens within a Forge component. You give the component a name, like in this example, News Hub, and then you can track additional actions for that. And those are data you will see in a later screenshot within the Amplitude backend. yeah. The second problems we faced were about the data collection within Forge. Also there, we had to store those events before they get transmitted to Amplitude. And we had to additionally compose Amplitude events with the help of the Forge context object, which is a tedious task we also solved. And yeah, this is basically what the challenges were about. Another problem was that the storage API is currently missing a query functionality. The solution we came up is pretty much what I've talked about just now. We compose Amplitude events so that they are compatible with the Amplitude API there with the help of the Forge context. So we can get another useful information about which instance is most active, stuff like that. And we implemented a fun pattern with the storage API with incrementing keys of those key value pairs. So we can get the latest events when we fetch for those click events and delete them when they are once read to don't hit any maximum capacity storage API problems here. What is interesting is probably though this TypeScript type. This is those are the attributes our Amplitude events have. So those are the information you can basically build graphs with the Amplitude. And you can also, it's the last line here, event properties, you can also add additional properties from your React frontend to those events so that you can do more interesting things like passing the information about certain configurations to your Amplitude backend and build graphs around it. The last issue has been data transmission. So how to pipe those data from the Atlassian Cloud to Amplitude. One problem we came across was about intervals of scheduled triggers, because we wanted to implement a controllable steady data flow here so that every click gets transmitted to the Forge backend and then to Amplitude quite frequently, but the lowest possible interval of scheduled triggers in Forge is, I think, 1 minute, which isn't that convenient. And so we build a solution for that uses, you can see it on the right here, it's called the Web Trigger API. So we made use of scheduled cloud functions. So this is a tool of Firebase, GCP, and you could also use the HWS for that. And we ping our Atlassian Forge app every 5 minutes, so we don't hit that 1 hour problem I've talked about. So the Forge app now pipes the persisted events from storage API over HTTP to Amplitude then. And we use the batch event upload API of Amplitude. There are a lot of APIs there, and we really went somewhat back and forth on it, but we felt like the batch event upload API is the best one here. The most fun part, the event stream within Amplitude. This is those are the events that get ingested around the News Hub component you've seen before. So we can now build diagrams and graphs around information like which user has changed the layout of their News Hub settings, for example. But there are a lot of possibilities here. And at the end, you can build diagrams like that. So this information is about when our news macro is rendered. And this is interesting for product decisions when you released new features and you want to know how many users are actually using it. Two last points before integrating that, you should probably talk to your legal team and be transparent to your customer that you're using data analytics, anonymize your data, and you probably want to give the administrator the possibility to opt out or opt into the whole process. And of course, read the Amplitude docs. This was about how we, and the code example I will share is about how to get those data from Forge to Amplitude, and how to build fancy diagrams and graphs around that is explained in the Amplitude documentation. Thanks for watching. If you want to have the code of our running proof of concept, just open that link. I'm pretty sure you will have to change it a bit for your use case, but yeah, I'm sure it will help you out a little bit because yeah, it's a running proof of concept and we are using it ourselves. Yeah, thanks for watching.